Before we get started, I first want you to think about this word motion. I want you to pause the video here in a second and write a list of words that come to mind whenever you think of this word, motion. So pause now and create your list. I'm not sure about the words that came to mind when you thought about the word motion, but some of the words that I thought about were speed, like going fast, and going slow. I also thought of accelerate, as well as turn, motion that's turning. And since we just finished discussing energy, I also thought of kinetic energy, which is the energy of motion. So hopefully your list has a few, if not all of these words. And go ahead and add these words to your list. So let's first start out by defining motion, which is the movement of an object from one place to another. So we start out in spot A and the object moves to spot B. The only way it could get there was through motion. When it comes to motion, you use something known as a reference point to see that motion has occurred. A reference point is a stationary point that's used to determine if motion has happened or not. Reference points are all around us, and so it's very easy to see when something is moving. It's very easy to see when your friends are walking down the hall. It's very easy to see a football that's flying through the air. It's very easy to see a volleyball that's being served because there are reference points all around, so it's very easy for us to see that motion. Even if we don't see the motion occurring, we know that it's happened because of reference points. For example, if your teacher was walking around the room and you were writing and then you looked up a moment later and your teacher was in a different part of the room, you might not have seen them move, but because their position relative to the reference points around them is different, then you know motion occurred. If there were no reference points, it would be very hard to tell if motion has occurred. For example, one time I went to the haunted mansion in San Antonio along the Riverwalk, and they put you in this room that is pitch dark, and I just happened to be the beginning of the line. And as I started walking into this room that was pitch dark, there was not a reference point in sight, and my orientation was very messed up. Very quickly, I could not figure out if I was at the front of the room by the door, the back of the room. I couldn't tell if I had moved to the left or the right. I was very, very mixed up in where I was. My orientation was completely off. And that's because I didn't have any reference points, any stationary objects to help me stay oriented. And so reference points are very important, and they help us see that motion has occurred. When we talk about motion, there's two different types of motion. There's forward motion and backward motion. Forward motion would be any motion that is away from the reference point, and we call this positive motion. Any motion that's backwards, back towards the reference point, would be negative motion. So forward motion is walking away from the reference point. Backward or negative motion would be back towards the reference point. Now, there are two words that I want you to be able to distinguish between, and that is distance versus displacement. Distance is how far an object has moved. And distance always goes forward. There's always positive motion. Distance never goes backwards. For example, if you took 2 steps forward away from your reference point and then 2 steps back towards your reference point, your distance was 4 steps. Even though you went forward and back, you don't add and then subtract those steps. You keep on adding distance. If you then took 2 additional steps, then your total distance would be 6 steps. And no matter how many steps, no matter if you were going forward or backward, your distance would just keep increasing and increasing and increasing. It's also like getting in your car. Every time you get in your car and you go out for a drive, the odometer, the mileage on your car, continues to increase. It doesn't matter if you're moving away from where you started or driving back towards where you began. The distance on your car is always going up and up and up, and that mileage is always adding and adding and adding. So distance is always going to be a positive value. It's never going to be a negative value. Then there's displacement, which is the total distance an object has traveled from its reference point. So how far away are you from where you began? Displacement can be forward, positive motion, or it can be backward, negative motion. For example, 2 steps forward and then 2 steps back, you're right where you started from. So your displacement would be 0 steps. Here's another example of distance versus displacement. We have a track, and there's 2 races on the track. There's the 100-meter dash, where you start here at the starting line and you sprint 1 length of the track and you end here at the finish line. So during the 100-meter dash, what is the distance traveled and what is the displacement traveled? Another race is the 400-meter dash, where you start here and you run 1 lap around the track and you finish right where you started from. So think about it for a second. What is the total distance and total displacement for the 100-meter dash and the 400-meter dash? Well, the 100-meter dash, the distance is 100 meters because that's how far you run. And your displacement is also 100 meters because you end 100 meters here. You end 100 meters from where you started from, your reference point. And the 400-meter dash, when you start here and you run 400 meters around the track, your total distance traveled is 400 meters. But since you end right where you started from, your total displacement, how far away you are from where you started, is actually 0 meters. So please understand the difference between distance and displacement. Here's another example in case it's still a little confusing for you. This morning, Marcus left for a business trip to Lafayette, Louisiana. He will travel 180 miles to Lafayette. Once his business is finished, he will travel 150 miles back to his Houston office. And at the end of the day, he will drive 30 miles home. So here's where he starts from. This is home. He travels 180 miles to Lafayette. And then when his business is finished here, he travels 150 miles back to his office in Houston. And at the end of the day, he travels the remaining 30 miles home. Identify the distance and displacement at each segment of his trip, but I also want you to identify when the displacement is being positive, moving forward away from the reference point, or negative, moving backward toward the reference point. So in his first segment from home to Lafayette, his distance is 180 miles. That's how far he's traveled. And he's 180 miles away from where he started from, and he's moving away from his reference point. So 180 miles distance, 180 miles displacement, and that is positive forward motion. When his business is finished in Lafayette and he travels another 150 miles, that 150 miles gets added to the 180 miles that he traveled earlier that day, for a total of now 330 miles of distance. He is 30 miles away from where he started from, so his displacement is 30 miles, and since he's headed back towards his reference point, his motion is negative. That's backwards negative motion. And in the last segment of his trip, we add 30 more miles to his overall total for a total of 360 miles distance traveled. And since he ends right back where he started from, his displacement is 0. And since he was headed backward towards his reference point, his motion, his displacement, was negative, backwards motion. There are 3 more words that I want you to be familiar with when we talk about motion. The first one is speed, speed of motion. The word speed describes how fast motion is occurring. When it comes to speed, there are 2 factors that you need to know: the distance traveled and how much time it took to get there. We use units like meters per second, miles per minute, kilometers per hour to describe how fast something is going. And when we talk about speed, when we describe speed, objects can move fast, they can move slowly, they can be moving at a constant speed where their speed isn't changing, and they can also be at rest when their constant speed is 0. Velocity is another word that describes motion. Velocity describes an object's speed, how fast it's going, and its direction. Speed, which we just talked about, only discusses how fast something's going, but velocity takes it one step further. It describes how fast an object's going, but also the direction of the movement. So see down here, velocity is speed with a direction. So the two factors that determine the velocity is the speed and the direction of the object. For example, if a ball is traveling 2 meters per second north, or 2 meters per second south, or 2 meters per second to the left, or 2 meters per second to the right. We have our speed, but we also specify the direction that it's moving. These are some statements, some example statements, and how we would describe an object's velocity. Fast, forward, which is positive motion. Slow, backward, or slow forward, which is also positive motion. Fast backwards, which is negative motion. Slow backwards, which is negative motion, and also being at rest. Acceleration is a third way we can describe motion. Acceleration describes an object's change in velocity. And there are 3 different ways an object can accelerate. It can accelerate by changing its speed. It can accelerate by changing its direction. And it can accelerate by changing both the speed and the direction. So the factors that determine the amount of acceleration is the speed of the object or the direction of the object. If this changes, then acceleration occurs, or if this changes, acceleration occurs. We can also visualize motion on something known as a motion map, which is a diagram that shows the position of an object at 1 second intervals. So here's a soccer ball at 1 second. 1 second later, it's traveled this far. In another second, it has traveled the same distance. Another second, it's covered the same distance. And in the last second, it covered the same distance. So you can see that this ball was traveling at a constant speed. Every second of time, it was moving the same amount of distance. This ball moves not quite as far in the first second. And then in the second second, it doesn't cover as much distance. And in the next second, it doesn't cover as much distance. It's still covering the same distance each second, so it's constant speed, but this time each second, it's not getting as far. So this would be slow constant speed. On this map, each second, our ball is traveling a little bit further. Still, it's traveling the same distance each second, so the speed is constant, but this time the speed is a little faster because the ball is covering a little bit more distance each second. So we have fast, constant speed. We also have some maps here. We have 1 second, and after another second, the ball doesn't cover as much distance, and the next second it covers even less distance, and even less distance, and even less distance. So the ball starts out by traveling further each second, so it's moving fast, and then it covers less distance each second, so it's not traveling as fast. So this would be an object that's slowing down. It starts moving fast because it's covering more distance each second, and then it slows down. It's not covering as much distance each second. And then our final map, we have our ball. Every second, it's not covering a whole lot of distance, and then it begins to cover more and more distance. So the motion of this object, of this soccer ball, would be speeding up. And that's all I got for you today. I'm out.